Welcome to this short introduction to the QSPainRelief database. With this video, we aim to highlight the functionality of the QSPainRelief database and its user interface. In order to access the QSPainRelief database, a user has to provide his login credentials. Should a user not yet have these login credentials, they can apply for access using the form in the link below the login page. After a successful login, the user can view the entire QSPainRelief database user interface. On the second tab of the About page, a user can review all the datasets that are available in the database, which also include a short description of the data. We will now present an overview of the different sections of the database and its functionality. In the Drug and Systems Parameter database, this contains information on physiology, drug pharmacokinetics in the plasma and the central nervous system, and drug binding kinetics. The user can select one of the sub-databases in step 1. As a first example, let us take CNS pharmacokinetics. If we calculate how many rows of data we will retrieve using the button on top, we see that there are 986 expected rows if the user were to download this data right now. We can see which parameters are present in this dataset by hovering over the Select Subtypes box. We can select, for example, the KP brain, and once again calculate the expected number of rows. This is now reduced down to only 52 rows. Let's visualize this specific subset of the data. We can do this by going to step 4. Here we can select different things related to the plot output, so the visualization. Important is that we select the y-axis variable of interest, in this case, the KP brain. We will keep the rest of the predefined settings the same for now. Note that the variable on the x-axis, drug name, is a categorical variable, and as such, this has been specified by ticking the categorical variable box. After clicking on Generate Plot, we can see the result. As the range of the values is quite large, it might be valuable to visualize this data on a semi-logarithmic scale. The app itself allows the user to do this by ticking the box below the plot. If we generate the plot again, we can see that we now have a log-transformed y-axis, showing better the range of the data. As there are many drugs available, the labels on the x-axis are a bit squished. To improve this, the user can open the plot in full screen with the button below the Generate Plot button, or alternatively, we can filter a few drugs of interest, for example, morphine and its metabolites. We can do this in step 2a. If we then generate a plot again, we can see that we have only selected these 3 compounds. The QSPainRelief database also contains information on clinical studies. These were either performed as part of the consortium or were historically collected data. This data can be accessed on the second tab. Upon doing so, the user will first face a pop-up window, asking the user to wait until the full database has been initialized. Due to the large size of the clinical studies database, this initialization takes a while. Now that the database is initialized, we can see that we have similar possibilities regarding filtering of the database as we had for the Drug and Systems Parameters database. Let's visualize some data that is present in the chdr.morphine study dataset, which is one of the identifiers that is present in this database. The preset plotting information will give a nice overview of morphine drug concentrations over time. If we would like to plot a different variable, let's first filter only on the specific database of interest. We can then select some new information that we want to plot. For example, the VAS score on the y-axis, time on the x-axis, and then we can select some faceting information. Let's choose drug 1 as the color. The line type variable will be drug 2, and the faceting information will be the drug 2 dose. Let's generate this plot. This plot now shows some other information that is present in the database. We can also plot some information from a different study, for example, the UCL Biopain database dataset. Let's filter on this data. We can plot pharmacokinetic measurements that are present in this database, also over time. And we can color and group by, for example, the demographic ID. We can also facet on the drug name to improve the information that is present in the plot. Finally, let's look at the Model Predictions tab. Here, the user can choose whether to focus on pharmacokinetic, PK, or pharmacodynamic, PD endpoints in step 1. The default setting is PD. We can see that there are two datasets present, both from the QSPainRelief partner ISB. Let's plot the default settings. This shows the predicted change in VAS compared to baseline for different combinational treatments. Aside from the desired effect, the change in VAS, we can also plot, for example, side effects. For example, the prediction of somnolence. These predictions are based on pharmacokinetic predictions used as input for this model. We can visualize these pharmacokinetics by changing the PD endpoint to PK endpoint, then choosing, for example, the single dose dataset. So this contains predictions after a single dose of a drug, changing the x-axis variable to time, and choosing concentration median as the y-axis variable. Let's change the color variable to simulated condition and the facet variable to the drug name that has been administered. This shows a prediction of pharmacokinetic profiles in different compartments, namely plasma and free central nervous system compartments, the ECF, ICF, and SAS, over time for different drugs. Aside from the pharmacokinetics, we can also plot the predicted receptor occupancy based on these concentrations by changing the y-axis variable to receptor occupancy median. If we generate a plot, we now see the predicted receptor occupancy. In the table of selected data, the user can see the exact data in a table form. This information can also be downloaded using the button Download Data, after which the user can do analysis or make plots that are better suited to their question. Thank you for watching the QSPainRelief informational video about the QSPainRelief database and its associated user interface. We hope to have shown you that the interface is easy to use, contains many different datasets, and also allows some preliminary data visualization and data exploration. We hope that this will be of good use to any researchers interested in the results of the QSPainRelief Consortium.